Are you with me that if someone was trying to market, say, a new vacuum cleaner, they might aim that at me because I love new vacuums. Okay. But if someone was trying to market, say, sports betting, but that shouldn't be aimed at you guys. It shouldn't be.
I'm talking about you.
No, sports betting is like...
I didn't know.
Yeah. Okay, so, but we have different ads aimed at different people based on who they think is watching that particular show, right? And even there's some shows like Antique Roadshow might have stuff for older people. Do you guys see what I'm saying? Right? All right, so people would, when we're trying to estimate age, we kind of care a little bit about the interval. For example, if I was trying to market a new product and I said, oh, this ad is good for people between 15 and 55 years old, is this an effective estimate?
No.
Not at all. Okay? Now, how many of us were right when we did this? Everybody. Everybody was within 20 years. Yeah. Okay? So when we develop this concept of we take our point, we take our p hat, and then we do our interval, and then we do our margin of error. Getting the point estimate, the p hat, is easy. You take your sample, you measure your sample. The rest of this comes down to how do we decide whether or not we should do plus or minus 2, plus or minus 5, plus or minus 20. Maybe we should have done plus or minus 7.2 years. So there's a balancing act between being right and being useful. This is not a useful interval. Now, if I'm only going to be right 2/3 of the time, that's not useful either. Because it might be a narrow interval, but it's not very helpful. Is everybody with me? All right, just so you guys know, Wyan looks a lot younger than he is.
That's 1 year old.
Arguably, I'm pretty sure his birthday's in July. I feel like last year it was like almost exactly 40, like the halfway point. Okay.
I actually guessed approximately 40 and a half years. I went for 42. I have it written on the paper. 40.5.
All right, guys. Notice, what was the width of this interval? How wide is this?
4.
4. What was my margin of error? 2. Okay. What about this one? 10. What was my margin of error? 5. So you guys with me? The margin of error is half the width of the interval. And your point estimate is the exact midpoint of that interval. Okay? And we are allowed to use p hats as our point estimate because the mean of the p hats is equal to p. So while none of our samples are going to be perfect, the mean of all the possible samples we could get is that actual value we're trying to estimate. Everybody good? All right. So I'm trying to estimate the proportion of kids who prefer dark chocolate to milk chocolate. This was my interval estimate. So I want to know what's the point estimate and what is the margin of error. There's 2 approaches you can take to answer this that are mathematically equal, in my opinion. You can either find the margin first and then use the margin to get the center, or you can find the center first and use the center to find the margin. It doesn't matter to me. Thoughts on how we could do this?
Subtract 0.65 from 23.
And when I do that, I think I get 0.18. So that's the width of my interval is 0.18, which means the point estimate is going to be half of that, yeah? So my margin of error will be, I divide that by 2, and I get 9%. And then once I know that, what I basically know is that point estimate is 9% higher than this and 9% lower than this, right? So we could just do either addition, subtraction, however you want to think about it. And I think we get our p hat point estimate to be 0.74. All right, now, if instead you want to think of this, because like I said, 2 different approaches, whatever makes more sense, we know the point estimate, which is p hat, is exactly halfway between the 2 intervals, or between the 2 endpoints. So we could do 0.6, we could find the midpoint between those 2 numbers and get that 0.74, and then say, okay, how far did I have to go to get to the endpoints? Like do 0.74 minus 0.65 and get 0.09. Both approaches are identical. So whatever makes more sense to you is the one you should use. Everybody good? All right, we got one more thing to talk about. So we kind of had just said that the margin of error comes with this balancing act where we want to be right, but we don't want it to be too wide. Everybody good? So how do we decide what the margin of error should be? All right, so sorry I forgot to change the example to a newer movie. But let's go ahead and pretend that Avatar just came out. It was about a year ago. Yeah, it was about a year ago. I know, I should have normally I put one like that like was out over winter break, but I didn't. Okay. Is that a P or a P hat? P. Okay. So this is the last time I'm telling the value for the population, by the way. Cool? All right. It might show up, it might not. I haven't decided which practice test you guys are doing for the final. Huh?
So for the first normal curve in like 3 weeks.
Is it normal?
Yeah. I don't know. I just.
Did we check to see if it was normal?
Well, I mean,
I just wanted to draw.
How do I check it?
0.45 times
1,015 times 0.45. 1,015 times 0.55. They're both close to a half, so I'm going to call them both half of 1,000. So I'm going to call that greater than or equal to 10. Okay, so we've got normal. We have the mean being 0.45.
That's atrocious.
Yours or mine? Mine's pretty bad.
No,
Mine is beautiful.
mine doesn't even.
Hey guys, can we find the standard deviation here?
Yeah.
It would be the square root of 0.55 times 0.45 over 1,015.
Your calculator now.
0.015.
Now, this 0.45 is P, it's the value of the population. If we each take a sample, they're going to be different, right? So there's lots of different P hats here. Is everybody good? Each of these are a different possible sample we could take. We're only going to take one. And it's going to be one of these ones, yeah? Okay. Let's pretend Miss Meister is P and each of you is a P hat. Where should I stand so that I'm close to most of you?
In the middle.
In the middle?
Oh, like
Like
in
I
both?
like right.
Yeah, in all directions.
Like
where
right
I think, like,
where I am.
This way?
Pretty much by Sev.
on.
Sev?
Right there, pretty much Sev.
Pretty much right
Right here?
As
But
on
a
the
little
there.
bit.
center.
That way. Just you guys.
Yeah.
Oh, right.
Because there's three of us here,
Yeah,
two
no.
up there.
Okay. Are we good?
Wait,
All
are
right.
we talking this way too?
Yeah.
Yeah.
To forward.
A circle.
What about height wise?
What?
Because then you'd have to.
Did he just call me short?
No,
No,
you have
you'd
to
have to like
squat.
go down even more.
Because we're all sitting.
Not too much though.
We're thinking 2 dimensional.
You brought it
Smart
up.
Alec.
You brought it
Smart
up.
Alec.
You brought it up.
Okay. Are you guys with me? That if I had to pick which P hat was Sev, it might be this one?
Yep.
Cool. And then if which one was Ben, might be this one. And Anagracia might be right here. And Landon might be right here. Do you guys get the basic premise of this? Okay. And poor Nadia. Nadia, you're here, right? Because Nadia is certainly the furthest from me. Right? All right. So for almost all of you, you're within this kind of like radius of me, right? And if you're within, let's go ahead and say we make our margin of error, that radius that everybody's close to me by, okay? Let's go ahead and say that we make it 10 feet. Is everybody with me? And let's go ahead and say Anagracia is 10 feet and Nadia, you're 11, which is maybe close to that, right? If Anagracia is within 10 feet of me, doesn't that mean I am also within 10 feet of her? And likewise, Nadia is not within 10 feet of me. Therefore, I am not within 10 feet of Nadia. Do you guys get this basic idea? Okay. So, as estimators go, all of you but Nadia would have been good if we used 10 feet as the margin of error. So that'd be right like 90% of the time-ish. Cool? Okay. Now, let's go ahead and apply this to the graph. We want to capture that true idea 95% of the time, which means we want to think through the middle 95% of the p hats would be close enough to 0.45. That, like, you guys with me? 95% is 2 standard deviations, yeah? So hear me out. Can we make the statement 95% of p hats are within 2 standard deviations of p? Does that statement make sense and feel good? Now, but when we think through this statement makes sense if you know what P is. Do you guys see what I'm saying? To figure out where is 2 standard deviations from P, you've got to know the population value. And in this case, we do. I told you it was 45%. But in the real world of statistics, do we know P? No. Okay. So we have to rewrite this statement so that it makes sense if we know P hat, which means P will be within 2 standard deviations of P hat 95% of the time. We good? Does this make sense? And in this case, the 2 was our critical value. And then it's going to be something called the standard error. And standard error is essentially, it is similar to standard deviation. Everybody good? Okay. So we are starting something with our first of many. We're going to learn a lot of statistical inference procedures. Okay? So the first inference procedure we're going to do is called a one sample Z interval for P. All right. So, our critical value is determined by how confident we're really willing to be. Okay?
So is that critical value always going to be the same?
That's a much more loaded question than you realized you were doing. So, always know. Because, for instance, what if I was okay with only being right about 90% of the time? Then I'm not going to use 2 standard deviations. I can use less standard deviations because I don't need as much of that middle chunk of my p-hats. Okay? So we calculate that critical value based on how confident we want to be. All right. So that critical value for this particular interval is a z star. Z is in the same z's we've been doing all year, which means the mean of the z-scores is equal to 0. The standard deviation of the z-scores is equal to 1. I don't know why I wrote 0. Okay? And the star just means it's a theoretical value, not the z-score of an actual observation. Rather, it's the boundary of the middle chunk. Okay? So if I want to find the z-score, the z-star for 90% confident, I want to know how many standard deviations from the center is the middle 90% of my possible p-hats. That's what the z-star tells you. How many standard deviations we should make our margin of error so that 90% of the time we're going to be right. Now, do we know how to do this? Okay. Cool. Please do so.
It's like 30 degrees outside, but it's hot in this.
He's running away. He doesn't like statistics. Hey guys, did you get a 1.645? Give or take? Okay, this is what that means. If I want to be 90% confident, my margin of error needs to be 1.645 standard deviations. Did you guys kind of get this vibe? And if I wanted to be 99% confident, I need to know how many standard deviations away is the middle 99%. So your z-star is just your number of standard deviations to incorporate that middle chunk of. And remember, each point on these is the z-score of a p-hat. Okay? So all the possible samples you could take. And I'm pretty sure this one works out to be 2.3. No. 5.7. So 5.88, or
2.5.
so my margin of error, if I want to be 95% or 99% confident, is 2.58 standard deviations. Okay. Does it make sense that the larger confidence has the larger z-score. If we want to be more confident in our answer, think about Mr. Wyan. We did much better with a plus or minus of 20 years than we did with, we felt more confident in our answers, plus or minus 20 years than plus or minus 2 years. Yeah. Yeah.
Is there a symbol for margin of error, or is ME just kind of like...
There really isn't. Yeah, I just use ME. Yeah. There is a symbol for what we call the standard error that's slightly different than the standard deviation, which is what we're going to be using. And we'll talk about that as we get kind of more formalized here. Now, in your head, you've thought about 95% being 2 standard deviations. That's an approximation. It should be 1.96, which is, we usually take those z-stars out to at least 2 decimal places. Okay, so I want you to get used to that 1.96, which again would mean my margin of error would be 1.96 times the standard deviation. How are we feeling so far? So one way, yesterday we kind of talked about that margin of error being this balancing act between we want it to be wide enough that we actually contain the true value, but narrow enough that it's actually a useful number. Yeah? Okay. All right. Now, whenever you do an inference procedure, there are 3 conditions that need to be met. Okay? And it doesn't make sense to do these procedures until these conditions are met. Okay? The first one is that your data has to come from a random sample. The reason it needs to be random is when we're doing inference, we're using the sample to make conclusions about the population. A random sample is the way we ensure that this sample is representative. Okay, the next one is that the sampling distribution needs to be approximately normal. The reason we need that, guys, how did you find that, how did you find z-star? We used inverse normal, yeah? So we need those p-hats, and in this case, the sampling distribution will be the p-hats, okay? We need those p-hats to be normal so that for calculation purposes. And then lastly, we need the selection of the sample to be independent. Basically because this whole distribution is based on binomial distributions, and binomials needed independence as well, okay? It has to do with the probability of getting a certain success each time stays approximately the same, okay? All right. So how do I check those? So when you get a question, it's going to be pretty crazy what the College Board expects you guys to write down. We're going to do a lot of practice with these, that you'll get used to all the details you need to include, but they're annoying about how many details they want you to include, okay? So the first thing you need to do is check the random condition. You do this by reading the question. And then however the question tells you that the random is met, that's what you write down. Okay? Does anybody remember when the p-hats will be approximately normal? NP and n times 1 minus p both have to be greater than or equal to 10. That's how we check that. We got a slight problem here. A really big problem here. The goal of a confidence interval is trying to figure out what p is. So if I'm doing an estimate for p, do I know p? No. Did you guys see what I'm saying here? So anything that uses p, but we don't know p because we're estimating it, we'll use p hat instead. All right? And then for independence, we never have it. Okay? Because if I'm randomly sampling I'm sampling without replacement, yes? When I draw a sample, and so our population is changing ever so slightly each time, we're still allowed to assume independence as long as my sample isn't too big. The rule for that is that the sample has to be less than 10% of the population. With small samples, you're not changing the population enough that independence won't be met. Okay. So, the formula for a confidence interval, we're going to learn 1, 2, 3, 4, 5. 5 different confidence intervals. They don't give you 5 different formulas for confidence intervals. What they give you, and this is on your formula sheet, is this basic thing. Okay? And then you're supposed to use the rest of your formula sheet to get there. Okay? So, what is our statistic if we're estimating p? P hat. Plus or minus. And again, I wouldn't expect you guys to remember this off the top of your head, but we are doing a 1 sample z interval. So your critical value is going to be a z star. Because it's for proportions, it's a z interval. We'll get deeper into those weeds. Okay? All right. Times. Our standard deviation is the square root of p, 1 minus p over n. That's on your formula sheet, yeah? Do you guys see, like, the structure's there, that exact formula for each different one is not. Cool? Yeah.
Why is it not p hat?
Thank you. Can we use p if we don't know what p is? So this is actually not p. This will end up being p hat. The standard deviation of the actual sampling distribution is p. Because we don't know p, we're trying to estimate p, we use p hat.
Is that critical value always going to be found using the z star?
Not every critical value is a z star. Every critical value in Unit 6 will be a z star. Is that a fair enough answer? Unit 7, we start talking about a different kind of critical value. And that's even more like myopic in terms of why we use what. Okay. Okay. And then how do you interpret your interval? Remember, like when we interpreted R squared, there was like blank percent of the variability in blank is explained by blank. The interpretation of a confidence interval is very much like that kind of Mad Libs formula, okay? You're going to start with something along the lines of we are blank percent confident that the interval from blank to blank captures the true blank. So for instance, if we do a 95% confidence interval, we would say we are 95% confident. The answer to your intervals are what goes here, right? And then this is going to be whatever it is you were trying to estimate in context. So this last part is how you put context into your conclusion. Okay. All right. Now, you do not need to use these boxes by any means. What the College Board expects you to do in terms of details is significant, okay? You have to do the conclusion, you have to check all your conditions, you have to do all your calculations. My experience is that if I give you just a blank page like they will, that students forget some of the details of what they need to include in their answer. The intention of these boxes that I'm giving you is to help you kind of have that visual cue of, oh, I don't have enough information yet, I do have enough information, that kind of thing, okay? So in the first box, so I'm going to structure all of my responses to the questions with these boxes because I think it makes more sense. We typically have the name of the procedure, the parameter of interest, and the conditions in this box. It just so happens that these boxes also correlate to how the College Board scores your answers. So in terms of like E's, P's, or I's, okay? When I grade your free response questions, I give you an E, a P, or an I. Okay, so on a question that's on inference, which there's guaranteed to be at least one, probably two, okay? They give you an E, P, or I for this set of things. Do you have them all? Do you not have them all? Then they give you an E, P, or I for your calculations. So we're going to put your calculations in this box. Cool? Does that make sense? And then in this box, your conclusions. So if you get into the habit, this will make sure you don't forget one of the pieces that you need to include, because it's a lot of pieces and they don't explicitly tell you to do all of these things. Does that make sense? Okay, so let's take you through an example of these. Like I said, this is not something that I would expect mastery of right away. All right? Right now, the name for your procedure will be really easy because you only know one. Okay? So the name of my procedure is going to be a one sample Z interval
Do we just like,
4P.
do we just list that? Or
Yes. And this sounds silly now, but I promise you that somebody later on is going to ask me, how do I decide what procedure to do? The fact that this says confidence interval tells you you're doing an interval, okay? That feels like it should be an automatic, you understand it. I promise you I've taught this for 15 years now. 10 years. 10 years now. Every year I get this question, okay? Okay. And in this case for P, well, P is equal to the true proportion of Grandview Heights residents who support renaming the gym. All right. Then we have our three conditions. So, you guys, is the random condition met? How do you know?
Takes a random sample of 513 residents.
So we're given that this was a random sample. Normal. We need to do NP hat, right? So I'm going to go up to my calculations box and real quick do P hat. Rule of thumb, don't write down a number without saying where it came from, right? So don't just write down P hat and give me the number to show me the fraction that got you there. What is it?
0.72525.
Perfect. So now to check that normal condition, I do 513 times 0.725. 513 times 0.275. And I should end up with 372 again, because essentially NP hat is just going to be your number of successes. Does that make sense? This should equal your number of failures.
141.
I'm sorry? Oh, that's a 1. Yeah. You can't tell that that's a 1, Blake? It looks like a 1 to me. And then independent? We're just gonna, and you guys, we're allowed to make assumptions, okay? We're gonna assume 513 is less than 10% of Grandview Heights residents. It probably is, but I don't know for sure. Yeah, I don't know what it is with the yard. It used to be roughly 6,000, but the yard probably has upped the population. Yeah. Cool? Is this making sense? All right, let's do the calculations. You guys, what should my Z-star be?
90%.
Okay, so Z-star goes with the 90%, but it is not the 90%. What was the Z-star when it was 90%? 1.645. And you can do that inverse norm, okay? The picture looks like this. Yes, no. The Z-stars are pretty, for the Z's, it's pretty ubiquitous. Like everybody know, it's like people know 1.96 is 95%. Okay, and what's my, okay, so we're going to use a different symbol for the standard deviation. We're using an S instead of a sigma. We do that when we're using p hat instead of p. When we're using a sample value, we know it's not quite as good. Okay, so what we end up doing then is we'll do the square root of 0.725, 0.275, all over 513. So we use an S when we have to use p hat instead of p.
So what are we trying to find with that?
So your margin of error is your Z-star time is a certain amount of standard deviations, right? So this gets you the standard deviation part. So the critical value is the 1.645. But that critical value is times that standard error. Okay? What are we getting?
0.0197.
So 0.020. Okay, and that would make, so now my interval would be the 0.725 plus or minus 1.645 times that 0.02. Let's go ahead and say if you currently are wearing shoelaces, can you do the minus side of that? And if you don't have shoelaces on, does everybody have shoelaces on?
I don't.
Okay, great, perfect. If you don't have shoelaces on, do the plus. Okay, so some of you do the minus, some of you do the plus.
Am I doing the plus or not? Oh, I don't have shoelaces.
You're doing the plus. You're doing the plus.
Wow, why am I so angry with them?
Because you make me
What are we getting for the minus? I'm sorry, can you say? 0.692. And then the plus?
0.758.
0.7579.
So
So
okay. And did you guys notice that I put my interval in increasing order? Like the lower numbers on the left That is something I'm going to be picky about. And when you read it as plus or minus, people tend to do the plus first and write that one first. Okay?
Does it matter?
It does. It needs to go least to greatest. Okay. So then we interpret this by saying we are 90% confident that the interval from 0.692 to 0.758 contains the true proportion. Think of that as the population, the P, of Grandview Heights residents who support renaming the gym. Cool? I'm done.